I remember at some point discovering Hex and thinking, my God, that is what I want. And I remember thinking like, wow, that's a sick product.
Welcome to Building with AI, the show where we engage in conversations with world-class AI product builders and leaders. We help uncover tactical insights to help you build and scale better AI products. I'm your host, Haroon Choudery, and today we're joined by Bryan Bischof, the AI lead behind Hex Magic. In this episode, Bryan digs into the inception of Hex Magic, an AI co-pilot for data scientists. He discusses similarities between recommendation systems and RAG, evaluation for AI systems, building effective AI engineering teams, and much more. But before we dig in, here's a quick word from our sponsor. Today's episode is brought to you by Autoblocks, the AI optimization platform product teams use to create world-class AI experiences. So, you just launched V0 of your AI feature or product. What's next? Autoblocks unlocks an intuitive yet powerful optimization workflow that helps you continuously understand, improve, differentiate your AI-powered products. Understand how your users interact with your product by connecting user activity to what's happening under the hood of your application. Improve your product thoughtfully and iteratively. Integrate testing of your AI products into your CI workflow and run A/B tests to see what changes are driving great user outcomes. Differentiate your AI products with powerful fine-tuning workflow that lets you turn product usage data into training data. Get started with Autoblocks for free at autoblocks.ai. Now, back to the episode. Bryan, welcome to the show.
Thanks a lot, Haroon.
So for folks who aren't familiar with you and the work that you're doing at Hex Magic, do you mind giving a quick introduction?
Yeah, no problem. My name is Bryan. I've been at Hex for about a year. And previous to that, I've been working in data across the stack for about a decade. I've been a data analyst, I've been a data engineer, a machine learning engineer, deep learning engineer, and I've led teams across the variety of titles as well. At Hex, I lead the AI team, which is Magic. We're building an AI copilot for data science and data analytics. Hex is already the best place to do data science workflows. So why not augment that with the best possible capability from an artificial intelligence or an LLM, really?
Yeah, I'm curious to talk through that story a little bit. Can you describe the use cases that Hex was specifically used for prior to the introduction of AI, or how the use cases had changed with the introduction of non-deterministic models into the code base?
Totally. I was leading this data team at Weights and Biases, and we were using a different product for our sort of data visualization, our data analytics workflow. I had a couple teams under me, and we really disliked the product we were using. It was frustrating. It was quite painful, honestly. And I remember at some point discovering Hex and thinking, my God, that is what I want. That seems so good. We need to buy that. And I really felt convinced that where the other product that we were using was going wrong was it was so centralized around a single SQL query and then riffing off of that. Whereas this like workflow that all the data scientists had already realized was powerful was such a great like place to centralize your work in that notebook format. Plus, I had seen that they sort of connected to your data warehouse and they also made publishing apps really easy. It just felt so natural. And so, as an outsider, before I had ever met a single person at the company, I was like a little bit of a fanboy. And I remember thinking, like, wow, that's a sick product. And then when I was at Redwood Research doing some research on LLMs, I was really finding myself asking the question, do I want to work in this space? This was in December of 2022. And I was wondering, do I want to pivot? Do I want to think about getting into LLMs hardcore? I've worked adjacent to them at Stitch Fix and worked adjacent to them at Weights and Biases, but it was never really my like specialty. My specialty was more on the recommendation system side and the forecasting side. And so I thought, maybe I want to get into this. And so I started looking into the capability and really getting into like explainability for LLMs. And I found myself really convinced that some workflows could be really improved. One thing in particular that I think a lot of people did was I did advent of code completely with ChatGPT and using Copilot. And I really saw a lot of places where it was great and a lot of places where it was not so great. And by the end of those couple months doing research on LLMs, I found myself thinking LLMs for data science could be huge. And Hex has an incredible product. Why not do this at Hex? They had just started working on Magic around that time. Barry's our CEO. And so back actually at the very beginning of 2023, he had started working with one engineer on prototyping something out. So by the time I got involved, it was February and they had a couple things that were starting to look like they were going to work. And that was where I joined the squad. Before, the product was this really wonderful experience to do data science workflows. Now the question is, how do you accelerate? How do you improve? How do you augment what's already great? And one of the things that's been really nice to work in that paradigm is I never have to ask the question, how do I build an experience for doing data science? I ask a different question, which is, how do I take the best experience for doing data science and make it better, make it more powerful, make it less frictionful, and make it faster?
Yeah, I remember the first time I used Hex many years ago, and I had the same sort of aha moment. Was this is so much better than being in a Jupyter notebook. The configuration is easy. The way that the cells run is much more intuitive. And so there was just a lot of ways that the tool had thought about how to help data scientists and other folks that were tinkering with data get to the end result much more quickly and in a delightful way. And so I'm sure AI blends really nicely to this entire workflow as well. As you mentioned, there's some use cases for LLMs on tabular data. And then you pair that with a tool that's already very focused on creating a delightful experience for end users. Is there any conflict between all of the work that's already been done to build up Hex versus thinking through things from the ground up?
Yeah, there's a couple things there. It's important when we are assessing Magic and thinking about building Magic that we ask questions about JDBD independently. It's not that we need to establish our own PMF, but ultimately, to a certain extent, we do. We need to get product market fit for our AI capabilities and our AI like features in the product experience. So we do have to ask, oh, we're thinking about like prototyping this weird feature for Magic. What jobs does it serve? What does it really do? And like, what will that solve for the user? It's easy to say like all the AI things are like to make you go faster or to make you like be able to do things you couldn't do. Maybe it's to expand TAM. But like that JDB framework is really powerful for asking what are the jobs that this user ultimately has to get done, and how is this going to be the tool that they reach for to do that? Even when you're working on capabilities that augment an already great tool, it can feel like you wouldn't be solving new jobs. You wouldn't be solving new problems because if the product's that good, then it must already. But actually that's not true. Our product is really wonderful for writing pandas. Why is it wonderful for writing pandas? Well, because it's got like nice autocomplete features and because it's got actually pretty slick syntax highlighting in ways that like normal Jupyter notebooks don't. And also the output from data frames are nicely rendered as a table. And actually the data frame output, you can easily filter that in the UI. It's already really great for writing pandas. But what does Magic add to the story? I can write a filter in pandas and I can UI adapt to a filter in pandas. But if I've got an annoying filter to write, Magic can do that even faster. I can just say, oh, filter this to when this column equals popcorn. And it's going to get that every time. And that's going to be faster than me. And that fits elegantly with the rest of our things. Let me give you a quick example. A few minutes before this call, I was doing some data analysis, of course. One of the things that I had realized is my inner join, I had a bad assumption about one of the data frames. I wanted to do this inner join in these two data frames, so there's a merge. And in particular, I was getting too many rows in the output. Why was I getting too many rows? Because these two keys that I was joining on, they weren't necessarily like perfectly unique amongst like the rest of the columns were unique. So the rows were unique, but these two particular columns weren't. And I couldn't quite remember how exactly do you only unique up the two columns on a data frame, but keep the whole data frame? Magic remembers. Now there's no special hex feature that like addresses that unique case, but that's okay because Magic has all the like know how to do that immediately, and literally 25 tokens away, I can tell it exactly what data frame I'm talking about as part of the command prompt. I can very easily get it to write that code in the cell that I already have. And all of the sort of like beautiful things that has been done at Hex before me, I just get to benefit from. So on that side, we're benefiting a lot from what was already great about Hex, but we still have to ask ourselves fundamentally, what are the jobs to be done for Magic? And how are we continuing to delight our users and make their experience better? The one last thing that I want to say is talking about the very first thing you mentioned, which is like, would it be easier to maybe start from blank slate? I have a lot of friends who are designers, and a while back, one of my designer friends told me the hardest prompt to get in some like consulting relationship is a blank prompt. Just make it great, and we'll give you feedback. Because it's much easier to work from a design guide, a design style, or a design aesthetic. And I've also gotten to benefit from that, not just on the design side, because that has guided us a lot too, but also from the sort of like architecture of the product. There's been a lot of times where the guidance that comes from having an established brand and product and design has really been useful for deciding what we want to build, how we want to approach it, and what might be a possible solution, but we haven't quite gotten to the right solution yet. I personally have not felt lusted for a blank slate.
What is the decision-making process as to how you prioritize the many different things that AI can go after in your product, the many different workflows that it can improve? Because it's different than how you might prioritize the different pain points, right? If you remove AI from the equation, it maybe adds a different element, and taking this into consideration, I'm curious, like, how do you prioritize and how do you decide what to go after first?
I think almost every SaaS tool has now a preposterous number of things that they could try to do with AI. We could try to build a customer support bot with AI. Should we? No, we shouldn't. We could try to build a chat with our like documentation for Hex. Should we? No, no, we shouldn't. Those are just like not that relevant. And there's a couple of reasons. One, what jobs do they serve? Okay, the customer support bot, it can maybe reduce the like amount of bandwidth that our customer support team has to spend working with customers. But right now, is that a focus? Not really. Actually, we're learning a lot from working with our customers. What about like chatting with our documents? It would serve the sort of like users who are sort of self-serving onto the product and trying to like get started with using Hex. Okay, that's important. That could be useful, but it's not quite the focus right now. And also, in both of those cases, those are pretty generic applications of AI. There is a high likelihood that there will be a purchasable solution in the next N months that works pretty damn well. I believe that like smart people are going to work on that problem. Great, we'll buy it. There are lots of great problems to solve with AI, and my team can't solve all of them, at least not right now. So what can we solve? And maybe even more importantly, what should we solve? Our persona that we are focused on is the people that know how to use Hex, and we want to make them better at using Hex. That focus on who we're building for has been really helpful for prioritization. Now, unfortunately, it is not the end all be all. That doesn't answer every question. There are lots of hard prioritization questions still about, oh, we have this research question. We think this might improve generations. We think this will make SQL completions even better. Should we spend time like prototyping this out? Or should we try to make generations faster? Maybe we'll try to speed up charts. And those are still very hard decisions. But ultimately, we have taken a sort of focus on one particular application, make it work, then make it work well, then make it feel great, then make it fast as hell.
That's great. And I love the framing of that. The first part of your answer there, it's almost a antidote to avoid shiny object syndrome, which I've seen a lot of companies just fall victim to since the ChatGPT moment. You can do so much with AI. It doesn't mean that you should do it all. And really just building guardrails around what are you uniquely positioned to do? What are the jobs to be done in your platform currently that you can facilitate in a better, more intuitive way? What does your persona want? How can you help them be better at using your product? These are great questions for just re-anchoring yourself and avoiding that shiny object syndrome. And as you mentioned, I imagine there's a lot of nuance in how you prioritize from there, because compared to traditional product prioritization, there are some additional factors for consideration. Obviously, there's additional trade-offs in regards to latency and cost and some of the complexity involved in building these features out, which I think comes as a surprise to a lot of teams that are working on these features, is how difficult it can be to make them work as expected. And speaking about the complexity, the hidden complexity sometimes of building these AI features and making them magical, I'm curious, what are some of the challenges that you faced when adding AI to Hex, especially the challenges that surprised you?
One thing that I have been mildly annoyed by is how challenging it can be to steer GPT-4 doing what I'm pretty confident I've explicitly told it to do. There was the days of sort of like stop writing markdown and just write code. And we've gotten away from that, obviously, with like function calling. That's been a great improvement. But there's other more subtle steerability problems when we're trying to provide excellent context to the model and it sort of just like ignores that context and we can't understand why. There's been much ado about hallucinations, and we too have investigated deeply hallucinations and made great improvements on hallucinations. But maybe I'll take a slightly different tack and just say that like we were relatively early on getting agents onto prod. A lot of people talked about agents. Agents here, for context, is having the model give some instructions to either other models or itself through subsequent calls on how to do things and then asking them to do it. Like agent chaining and agent pipeline, we had started putting into prod in September. And I think we knew that we were early there. We're prepared for a little bit of a rough go. But I think it was quite, in fact, there's a lot of difficulty in terms of like accurate plans that were actually followed. And then we were also aware that there was going to be a lot of entropy, which is to say that you introduce a source of complexity and it's writing instructions for other agents. And those instructions are all sources of new entropy because everything it writes, you're no longer controlling. And we kind of knew that this was like a potential problem. It really showed up as a significant detractor from the quality. We would see that sometimes what it was writing for the other agents was just nonsense. And so I would say, even coming into the agents conversation, knowing this is hard, planning's hard, it was still hard. It was still even harder than we necessarily expected. And then to cap all that off was just the latency was really beat us over the head. Starting in like May, I was telling people be careful of any agent chains because you're going to be invoking a lot of latency. And I sort of went off and did what I told everyone not to do, which is underestimate the latency costs. And then the one last thing I'll say with evals, like I've been like a hardcore evals guy since like February of 2023, which is, I guess, now a whole year. I felt like I was very, I'm so smart. And I found myself trying to build evals for agent chains and being like, damn, this is hard as hell. I think as much as I have strong opinions and feelings on evals, when you start building them for agent chains, it really does level up that complexity. Those are some unexpected, despite being like clearly anticipated challenges.
Regarding agents, it does feel almost like we're trying to drive a 16-wheeler with loosely screwed tires, right? The technology isn't reliable and accurate and trustworthy enough that we can really build that complexity into it, right? Layers and layers of complexity. Do you think we're anywhere close to having powerful agent use cases that are actually accurate and reliable?
It's not easy. I don't claim it's easy, but I do claim it's doable. And I do claim it's valuable as hell. We released Magic Analysis, which is a sort of like step-by-step process to generate an entire notebook from a single question. It works step by step. It produces a number of cells. It is at its infant stage. What it generates tends to be on the shorter side, intentionally so. And what it generates is mostly focused on one question, but we are expanding that to understand more and more about what you've already done. And those work through agent chains and agent pipelines. I talk about this as being a control plane sometimes. There is what you need to develop as a control plane for all of your agents, and all of your agents serve as like microservices for doing things connected to your application stack. They could be like simple things like go and do this very deterministic thing. They could be more complex things like go and ask an LLM to generate this kind of response. All in all, though, I think where we found challenge, but also eventually success, was in building that control plane first and really iterating on what that control plane needed to look like. Our first version, our second version, our third version, they did not work. They were nonsense. They were shitty. We have made a lot of improvements and now they actually work, but it was not a first 3 tries type of thing. That being said, I do think that this is the direction that we will go. And I think it's also a borderline trite to say that like the secret here is tight interfaces. The more and more that you can constrain those handoffs and think in the classic composability framework from machine learning, the more that we've had success. This is not something that I didn't know when I was starting on agent stuff. It's just something that you still kind of have to swim around in the dark until you bump into the walls. And yeah, we've gotten there, but man, it is taking a lot of evenings and weekends to really poke at some of these dark spaces.
Yeah, and is the expectation there that the constraints that you've added right now will expand over time as the technology evolves?
Yes. It will also expand as we have more time for experimentation and have more time to just test the limit. As an example, sort of like if currently we can generate chart cells, code cells, SQL cells, markdown cells, great. But what about filter cells? And what about pivot cells? And what about all the other important features that Hex brings to the table? A great magic analysis agent based system leverages Hex with all his power, not just some of his power.
Got it. And you mentioned something there about evals and misconceptions around evals in agentic applications. What are some of the nuances of evals when working with agents that you're referring to?
Yeah. Let's say you have an agent pipeline and it's 3 steps long. If something goes off the rails at step 1, you never get to step 3, which means if your eval is tied to step 3, it's a fail. But you actually just lost signal. You lost signal on like step 3 and step 2. It failed at step 1, so you never got there. So you naively say, okay, I'll put in the Oracle results for step 1 and step 2, and I'll just test 3. Neat. But like you still are missing signal. Putting the Oracle results in 2 and 3, you're still missing signal. And what is the signal that you're missing? How close does it need to be at step 1? Do you put in like Oracle results warped? Do you like transform those results a little bit? How close does it need to be? Let me give you an example. If you have an agent pipeline and your first thing says, I'm going to make a plan, and my plan is I'm building an agentic pipeline to make dinner. The first agent is going to go find a recipe. The second agent is going to wait for that recipe and then calculate what grocery items we don't currently have. The third agent is going to learn what we don't have and see what is available at Whole Foods from that list. Everything that's not available from Whole Foods is going to be passed off to the fourth agent to go to, let's say, Target. Okay, great. So we've got 4 steps, lots of room for error. So your first agent is going to pick a recipe. Cool. It retrieves a recipe in Japanese. Okay. Does your second agent read Japanese? And even if it does it know how to compare like ingredient lists in Japanese versus English? Huh. Okay. That was wrong. We can put a real recipe in and just check the rest of the pipeline. Neat. But what about this Japanese case? Should we be checking for Japanese? I doubt it. What are some other variants? It could get back the recipe and the ingredients could be at the bottom of the list. You can see it did the thing mostly right, but it's not quite right enough to hand off. And you really start to, and this is a very silly example, so it's easy to poke holes in why this is different than prod. But what I assure you is, as clever as we can be in terms of poking holes in this analogy, GPT can be clever enough to make up other dumb ways to be wrong. What I will tell you is that this is the kind of weird, like, difficulty in these evaluations. Like, as much as you feel like you're constraining it, there are still really big gaps in what you're looking at. This is why I don't love super strong binary yes or no at the end of the pipeline evals, but I also don't like agent-based evaluation. I think reflection is mostly snake oil. So at any rate, I think there's only one cure for this, and every data scientist already knows the cure, which is you look at your data. Jason said on a previous podcast something similar, and I have to agree with Jason here, is that, like, yeah, you got to look at your data. I was at some dinner recently with one of the head of AI from Notion, and she was saying that they have, I think, biweekly data looking parties where they just look at the inputs and outputs from their AI and they just learn where it's making mistakes. And I thought that was fantastic. And that's something that we've done a bit of here at Hex as well. And I'm very inspired by them doing that.
Actually, Autoblocks users mentioned to us that they're doing game film sessions each week where they look through user inputs and feedback. And it totally makes sense. And so our evals, let's say for non-agent applications, where are they most useful in that case, right? So you mentioned the binary true false is maybe not super useful. You mentioned other types of evals are maybe misleading in their usefulness. What is a useful application of evals that you think, in your opinion?
Some binary evals can be very useful, but what I would say is, here's where I really strongly believe in evals. Take some capabilities that you think the agent should get right, 100% right. And now when I say 100% right, make sure you quantify what you mean by that. Let me give you an example. If I tell the agent, here's my users table, and my users table has a user ID, username, user country column, and I tell the agent that, and I say, write me a Snowflake SQL statement to query my users table for the number of users from the United States. This is something that I expected to get right. This is the kind of eval that I want to build as a binary. How do I check if it's right? I need to check that if I run the query that it gets me back, this is called execution evaluation. If I execute the query that it gets back, that it gets the right answer. So I go out to my table, I pull down a table, I like make it available to the response. I run this against it. I know what the real answer is, and then I run the agent's response. And I say, are they the same? There's my binary evaluation. But guess what? That's a bad eval that I just described. And here's why. Because I didn't tell you what the column needed to be called. And I didn't tell you what order it needed to be in. I didn't tell you that it shouldn't have any extra columns. I didn't tell you any of that stuff. Those are all opportunities. If you just compare the output of data frames, you're going to get the wrong answer. So then you introduce something called relaxations. Relaxations are ways that it can be like a little bit less strict, but still right. And so go ahead, check if those data frames are the same, but also check that the data frames are the same by dropping all the column titles. Check if the number's anywhere in the data frame that it returned. Maybe that's good enough. I think that binary evaluations are really, really powerful and frankly, the most important thing to build, but you really have to build them in a thoughtful way that is almost like adversarial, because there's so many ways that like there's fuzziness in what you said. Now, what are great things to be evaling all the time? Capabilities that you think the model should never screw up. If you tell the model, here's the table and here are the columns, write me some SQL. You told it the flavor of SQL, Snowflake. You'd hope it would be good enough. Now, granted, in the last 2 years, we would hope it be good enough. Before that, we were less opinionated. But nowadays, we think that it should do well. And this is really powerful to be asking all the time. So what are some things that you should be evaluating that maybe it doesn't get all the time? What if you don't tell it the flavor of SQL? What does it default to? What if you purposely leave out the country column? What if you don't tell the format of the country column? Now we're starting to get a little bit more dicey. Some of those things we don't expect it to get every time. And as you introduce variants on these questions, so you don't just ask the customer's version, or you don't just ask the version where the customer's table is so elegantly like filled out, then you start asking yourself, what percentage of accuracy would you expect? These are the opportunities for binary evals. You can build up and should build up a corpus of these things that you expect to get every time. But it is, in my opinion, a scaffolding process. And I really believe that like you want to know these core functionalities, yes or no, every time. New model comes out, anything in this list fails suddenly, because they better not. Let me give you a great example. Function calling came out. If we switch to the new model, but we don't use function calling, does it pass all our baseline tests? These are all the tests where is it thinking at all? Does it fail any of those? Actually, yes, it does. So like clearly the new model is not like happy with our context construction. So we know that we have to change context construction. These are the kind of things that are really important to be checking all the time. And I just listed one last thing as a long answer. I just talked about like context construction. Like you also need to use this because you want to be able to A/B test very rapidly things like, oh, before I was providing all the context, all the table context is just a list. Maybe I'll just include it as a YAML. Does that work better? You want to be able to check that really fast on the things that need to be the most confident. So anyway, long answer, but yeah.
That has to be the best explanation of building good evaluations that I've ever heard. That was great. Yeah, that was awesome. I mean, do you think that there's a strong case for synthetic data startups, just given the need for evaluations to cover all of these different use cases? Is maybe you have a use case and you use a synthetic data generator to come up with just many different versions that could potentially poke holes in your product during testing?
Yeah. There's like two thoughts here that I have. And one of them is a little bit like mysticism. And the other one is a little bit more scientific. But the mysticism one is like, it has never rubbed me the right way to think about a model generating data for itself. That's always been something with I've done too much ML to really trust that. And so I'll start with those priors that like I'm always a little bit skeptical. You tell me you're going to use like GPT-4 to generate data for GPT-4, and I'm already like, But okay, let's move on. Let's say fine. You know what? These models are big. Too many parameters to worry about something like that. Let's just move on. Okay. I have another feeling, which is I've not had great luck with synthetic data. I believe that it should be reasonable, but I personally have not had good luck with it. And I don't have a super great understanding for why. I've used it to take evals that I have and generate more. I've used it to sort of take existing context and rewrite it and try, 25 variants of rewriting the context. I've tried it to take a system prompt and rewrite it 100 different ways, the same content 100 different ways to see if any of that makes a difference. I have tried it to both compactify and expand prompts. I have tried it to rewrite my function definitions. I've tried it to rewrite my function descriptions. None of these experiments have worked. Not a single one. Now, I think I just listed 5, maybe 6 of them. All of them are things that I've seen on Twitter, people saying, I've done this and this 10x. None of them have worked for me. None of them have shown any statistical significant improvement on anything. The one thing that I've had a ton of luck with is here's a very unstructured set of data. I want to turn this set of unstructured data into evals. I basically have a recipe in my brain for how to do it, whether it is textual descriptions of SQL that people already wrote, or whether it is sort of like a bunch of sourced questions from my company, or whether it is a sort of big corpus of stuff I find on the internet that I want to crunch through. And I, Bryan, sit down and say, how would I take 1 or 2 or 3 of these and turn them into an eval or turn them into a sort of like example. I do that process, and then I describe that process to ChatGPT, and it will then crunch through my unstructured data. This is why I believe that right now, anyone who's in the space of sort of like hooking up LLMs to ETLs for unstructured data processing has a lot of opportunity. I think this is a really sick opportunity right now, but I haven't personally had a lot of luck with the sort of like fundamental. I know a couple of companies have tried this, like type in some words and it generates you 1,000 perfect evals for your use case. I haven't seen it. I've tried. If someone can show me how to do it, I'll buy him dinner 5 times. I just really truly, I'm honestly a little bit burnt out on trying it.
Okay, so I want to shift gears a little bit and talk about retrieval. And for those that don't know, you've written a book on modern recommendation systems, literally. And so you're the right guy to talk about this. And I've heard from so many folks, so many companies that I talk to, that retrieval is really where they're spending most of their bandwidth, is engineering their retrieval systems, trying to get the right data and context into their prompts. You made a really interesting analogy on a separate podcast with Swix, where you compared RAG and retrieval in the context of generative AI to effective recommendation system engineering. Do you mind elaborating on that a little bit more, and also just chatting more about your background in recommendation systems?
Like one of your previous guests, I also worked at Stitch Fix on recommendation systems, and we are, I guess there's some indoctrination or something there. But the approach I take in my book is an idea that I stole basically from Even Oldridge and from his last name's Higley, but I can't remember his first name right now. I feel bad. Regardless, which is this 4-stage recommender. And they originally had gotten it from a Eugene Yan post. And Eugene's a really phenomenal writer about recommendation systems. And the 4-stage recommender is the very first thing that you need to do is retrieval. And then once you do retrieval, you need to do ranking. And once you do ranking, you need to do serving. And so those are the 3 things in my book that I really pivot the whole book around. There's a really beautiful diagram from Eugene originally, and in his version, it's a 4-stage ranker, but in this like sort of like boiled down 3 versions, retrieval is the process of getting the things that you might serve to the user. Ranking is the process of, from that subset of things that we think are appropriate and relevant, which are the most relevant for this recommendation. And serving is the process of getting it to the user and getting things that shouldn't be sent to the user out of there. Now, in the book, I talk a lot about different aspects of this. And we talk about, I have a co-author, his name's Hector. We talk a lot about, okay, retrieval. What do you do with a retrieval system? You can do top K in some sort of like latent space. Neat. But retrieval is a lot more than just top K in some latent space. You have to ask the question about what latent space. You have to ask the question about what query vector. Fun fact, in my interviews, I like to talk about what's the biggest challenge about sort of like RAG systems today. And the biggest challenge of RAG systems today, for anyone going to apply to my jobs, the answer is basically like the query vector looks nothing like the vectors you're trying to retrieve. In my case, I'm trying to retrieve tables. I'm trying to get back the relevant tables for the users to write their SQL against. And they're not writing natural language that looks anything like a table. You think their natural language looks like a table schema with the database called out and the type of 1,000 columns? I promise you it doesn't. And the ADA encoder doesn't know that those should be the same thing. So my challenge usually in my interview process is a little bit around the question of like, how do you expect retrieval to be any good in this context? And this is a question that recommendation systems people are very familiar with. If you ask a recommendation systems person, hey, I want to build an image recommender, and I want people to be able to type in questions about like anything and get back images that like answer their question. The recommendation person says, oh, You have natural language and you're trying to match it to images. What embedding are you going to use? And more modern times, we'll say clip. Oh, but that's not what clip does. Clip is actually descriptions of the image. This is a different problem. You want to ask a question and have it answered by the image. That's not what clip does. Where are you going to build your encoder? And so that's a thing that recommendation systems people are really trained to do. Ask that question. How do you expect your retrieval to work? And so that's the first piece that I think is really related to the RAG system. The next piece is re-ranking. You get back your top K. Maybe you figured it out. Maybe you have a great embedding. People these days like to chunk. Chunking is taking the data and breaking it into pieces so that it looks more like the query. Or maybe they'll even do hide. They'll make up hypothetical questions that can be answered by the chunk. Neat. That's great. That's a better embedding than we started with. But when you get those responses back, are they the right responses? Are they like relevant for your retrieval pipeline? Jason, one of your previous guests, talked about like business value in RAG. I think that's exactly the right question to ask here. Does your high recall score correlate to what your users want? Let me give you an example. If you have a RAG system over like Wikipedia, and you're going to have the user asking questions specifically about what a country's capital is. That's the famous one. What is the capital of France or something like that? Neat. It's going to look up the chunk of data that is about France, and it's going to say, oh, neat, the Wikipedia on France has a thing that it says about capitals. But the Wikipedia page about historical capitals has about 15 of those. So now you've got 15 chunks on one page that all correspond to the capital of France. And you've got one on the core page for France. Which of those do you send to the model? Do you send them all? How do you know which one to send? How do you know that the one is going to be magically the closest in your latent space? We all know that it's 1600 dimensions. Everything's close to everything and nothing's close to anything. So what are you going to get back anyway? What hope do you even have? Oh, we'll just send them all over the model. You got plenty of context. Yeah, but there's a limit to that. Not all RAG problems can handle the whole chunks that you get back. So which one do you send? That's a re-ranking problem. You have to figure out in real time how to send the right one over. Variety of different strategies. Some of them you can steal from Rexus, some of them you can't. Lately, people have been talking about re-ranking, like naive re-rankings, just from getting back, like basically like people have talked about doing collaborative filtering. They have a very sad story in front of them because collaborative filtering doesn't work for these kind of retrieval systems. Turns out that you can't collaboratively filter when every query only appears once in your data set. So then those are the first two problems of RAG. And then the third problem is serving. In this case, the serving is not to the user. The serving is to the model. How do you get that data over to the model? What other things do you need to include? For us, on the process of like you're done with your RAG system, you've gotten your table information, we need to get some other information related to the table that can be really helpful for writing great queries into our table retrieval pipeline. And so we have some additional steps, and that's part of our serving logic. Now, in recommendation systems, you care about that too, because, hey, this is a great shirt for Bryan. What size does Bryan wear? That's something you do at serving time. Oh, I was going to recommend this to Bryan, but I just realized Bryan's allergic to cotton. I can't recommend this to Bryan. And those are things in the recommendation system side that we're used to dealing with. Everybody in Rexus knows this. That's okay. How do we steal this in LLMs? I need to add in for some more information about tables. Oh, and I should not recommend this table because the user has told me I don't want Magic writing queries against this table. And that's something that you can do in Magic right now. You can forbid tables from Magic. We call this exclusions, and it's literally using the exact serving logic that I described in my book. So ultimately, all three of these pieces are part of the RAG system, and they're just exactly the same problems that we've been solving in Rexus for years.
Yeah, can you talk a little bit about Data Manager and the role that plays in helping you unlock the most value out of AI on tabular data?
Absolutely. So a lot of people want to solve text to SQL. And I think it's not a very big jump to get to the like, oh, well, the hardest part of text to SQL is you don't know what data they have. And so people say, okay, like just like tell the model, what are you going to tell it? Are you going to tell it like the table name, the table columns, the table column types? Okay, it's a good start. What about the table descriptions? Neat. That'll help. What about the values in the columns? That'll help too. What about the relationships between the columns? What about the columns that are good and the columns that are bad? What about the tables that like only certain engineers should query? What about the schema that nobody should ever query with Magic because it's literally for DBT to use and nothing else? These are all the things that we have exposed through the data manager. The data manager is not a new concept. People have been building this for humans for a while. We just happen to sort of like really prioritize it for LLMs. And so at the moment, this is an interface for all Hex users to come and describe their data warehouse so that Magic has the best opportunity to write really useful SQL.
Yeah, that makes a ton of sense. A lot of companies, it seems like, are trying to work around those problems, and it just seems like one of those problems where it comes down to what you said earlier. It's like the AI is not just going to discover the context on its own, right? It's not going to magically just understand some of the questions that allow users to explicitly answer in Data Manager itself. And so it's interesting and great to see that you're taking that approach. I'm curious to learn more about retrieval techniques that haven't worked. So this is a question from Greg Kamrat, who's a previous guest on the show as well. He asked, what commonly used retrieval technique didn't work, and why do you think so?
Just look up the tables from the table schema. It just doesn't work. And like, it didn't take us very long to figure this out, but it was where we started, which is like take the whole schema, dump it into Ada, and then query against it. We really did have to go through multiple iterations of retrieval. And in fact, I can't get into too many details, but I can talk about the fact that like we're not actually doing table retrieval in that form at all. We're doing a more sophisticated technique, also stolen from the rest of space, but it's a lot more subtle on like how it's related. This sort of very basic of every point in space is a table, and you just want to find the magic set of like tokens from the table description that is going to map to all your queries. We were unsuccessful in doing that, and I don't believe in that as an approach. And so we did have to rethink not just what we're embedding, but like really how we go about doing retrieval. And this isn't so much on the like approximate nearest neighbors algorithm. It's more on the sort of like thinking about the contours of our latent space and what we expect to be close to what.
I see. And some other questions around just how your team is developing these AI features. Taking a step back, what does the team look like that's building Magic? Who are the different stakeholders that are involved in bringing Magic to life?
Yeah. As far as personnel, it's broken up into sort of like AI engineers, parentheses, data scientist, and AI engineers, parentheses, full stack engineers. We're very lucky that we have a lot of like full stack talent on the team. And so people that can not just prototype these things out, but really go and build them into the product. And we've been really blessed with phenomenal talent. And on the data science side, the ability to kind of like dig into the data, understand really like what's going on, and write really hacky prototype shit just in Hex projects to see like kind of like what's possible. One of the fun things is we do most of our AI development in Hex. We build Hex notebooks that we can explore how the model is going to behave. And we have a lot of, I would say, like wrapper and framework so that we can easily prototype stuff out. It could be better, and we're working on improving it, but we do have some ability to rapidly iterate. And so those are sort of from the personnel perspective. We've also been really fortunate to have like design bandwidth afforded to us to kind of like make sure that design is part of the story from soup to nuts. And because of that, we've gotten a lot of great inspiration on how to make these user experiences feel natural. Because ultimately, most of the capabilities that we've built, if you put them in a crappy wrapper that like people don't know how to use, no one will use them. They're way too complex and way too nuanced that you can't simply put it in a chatbot interface and expect it to really like do anything for anyone. And so we've been really fortunate to have that design bandwidth too.
I'm curious to learn more about using Hex to prototype some of these features. It seems like a very natural tool to be using. What are some of the additional perks that you get when you use Hex for prototyping versus just a plain Jupyter notebook?
Yeah. So we have these things called components in Hex, which are like reusable code snippets. I'll define a reusable code snippet for a particular kind of like magic endpoint. So maybe it calls one of our internal endpoints, or maybe it calls to like OpenAI with one of our prompt construction templates already included. Or maybe it just pulls down the data from previous magic requests so that I can poke at it. And those components have been really helpful. Input parameters is something that we offer. We have like these cells that you can kind of like adjust the input parameters. They're so like trivial in a certain sense, but they're so valuable in another sense. Do I want to quickly like look at all instances of this particular template where this particular thing happened? Oh, I just changed this value in the column like input parameter, and it's so rapid. And then the reactivity kind of really like puts it all together. I share applications with my team of like, here is a set of examples of this behavior that we've been noticing on prod that we think is concerning. I've written a little scraper that like detects this behavior, and here's all the instances over the last month. Can we figure out what's going on here? These are the kind of things that like, can you do it in Jupyter? Yeah. Yeah. But like, is it much more cumbersome? Yeah.
And so when you're deploying some of these prototypes into production, when you're rolling out some of these new AI capabilities, how are you keeping a pulse on how those features are being received in production and instances of hallucinations and maybe potential test cases that you can add into your evaluator suite that cover edge cases that you hadn't considered before?
Yeah, absolutely. Because we are a data analytics company, it will come as no surprise that we look at the product analytics. We do have product analytics that we try to keep really top of mind. We have the sort of like obvious accept reject type metric, which is on average, how often do people accept our suggestions? But that's I would say, the beginning of the story, far from the end. Deeper analyses into things like hallucination, deeper analyses into things like code differences. How much does the user change the code after they accept a response from us? This was a metric that we stole from GitHub. They have a great blog post explaining why that's a good metric, and we very much agree. But we have a lot of nuanced metrics. The sort of obvious product analytics, which I do think are important, but layering on top of those more nuanced ones that make sense for our product. Like any data scientist, I always start with the sort of basic things that every product cares about. How well do your users retain? But I then try to find what are the nuanced early indicators that things are going well or things are not going well. And that's just like standard, like bread and butter data science. And I think Hex is uniquely good at surfacing all that. And so it's pretty easy to get done here. But yeah, I definitely think that it's worth the effort to take that data science approach and really look carefully at what your model is doing. I know there's been a lot of like consternation about who are AI engineers. Are they like ML engineers? Are they just software engineers? My sort of maybe inflammatory comment here is that like I think software engineers can be AI engineers now when a lot of the work is plugging a plug into a plug. But as we get deeper into the distribution where we're trying to get at more nuanced use cases, we're going to want more of the like data science profile to be part of the team to help understand what's going on and how do we fix these problems. And so I think a really well stacked AI engineering team has at least a couple data science background people.
I feel like we could do another episode just based on that comment right there. That's fascinating. I haven't thought about that yet, but it's a really interesting line of thought that I'm going to ponder on tonight. And speaking of some of the nuances of working on a AI product team, many months into working in a team that's building LLM powered products, what are some of the differences and nuances and quirks of developing products in this space versus non-LLM powered products. And I would, obviously you have to try to isolate the quirks of working at a Hex or something like that from the answer.
I laugh because I also ask this in my interviews. This is one of my favorite interview questions of sort of like, what is the differences? I think it's important to have analogies. And I think an analogy from software systems that like people building these products needs to hold: really tight interfaces will save you a ton of headaches. The more that you can think about your systems as having like really firm contracts, the less pain you're going to endure later on. That includes the sort of like integrations, but that also includes the like upgrades and changes. One of the things that like I talked a lot about when I was working in ML ops is composable systems. And that's because in ML ops, one of the sort of like the best things you can do is iterate fast on different components of your system. But if you want to iterate fast, you damn well better know what your interfaces are, because if you don't, you're not going to be able to like interface, and then all that iteration speed is going to go out the window. So the first analogy is from software systems, which is I really, really, really believe that tight interfaces are important. The next analogy I think is really important from like traditional software product. Like, I'm not a product manager. My wife is, but I'm not. And one of the things that like I think great product managers and great product engineers are good at, like what they're great at, is asking questions like we started the interview with about JDBC. Like, what is the job to be done? What does this do for our user? Why is our user unable to get this job done other ways? If we don't do this, what are they going to do? Let's assume they're still going to get their jobs done. What are they going to do? Understand that question and understand how to make that answer use our product, and what's the easiest, fastest, but most consistent path to get us from here to where our product is what they use to solve that problem. That is something that like great product managers are great at and great product engineers are great at. And I think is absolutely 100% true for AI systems. I think the biggest mistake you can make in building AI systems is thinking that like you don't need to care about the job to be done. And for whatever reason, I think people get too excited about a capability and they stop asking this question. And so that's one thing that I think is like really important from that side. From the ML and data science side, I think you then have to ask your question of like, what are the behaviors and what are my expectations about getting these behaviors to emerge? And so when you start building an ML system, you ask the question, well, what is the problem that I want to solve? And how am I going to frame that problem in a way that's related to my training data? And then where will I get that fucking data? When I teach master's level data science, and I usually start the class with the following. The very first problem as a data scientist is problem framing. Frame your problem. Understand what your problem is. The next problem is objective framing. Figure out how your problem is related to an outcome. The third problem is data framing. How do you get from your objective to data, or from your data to your objective? These are the three like most important tiers of the beginning of the machine learning process. Because if you don't know what your problem is, if you don't have an objective function, what will your model train? What will your model learn? And if you don't have data, how will you train it? It turns out all of these things are true for LLM applications. You have to know what your problem is to solve it. Your objective function is, what are you trying to map this extremely entropic and vague output into? Why was function calling so exciting? It's because it allows us to do objective framing. It really allows us to take this weird thing and jam it into the box that is shaped like our problem. That is objective framing. And then third, data framing is, what data are you going to collect to allow the model to be able to do this in a few shot paradigm, for evals, for understanding aberrations or sort of like the misbehavior of the model? This is all data framing. So all three of these things are still absolutely essential for AI engineering. They just sound a little different. So those are the analogies that I think are really important when building these products. It's funny because there's only one wrong answer to my interview question when I asked this question, which is one of the former. If your answer is one of the former, you're wrong. Anything else is right. You can tell me it's mostly software engineering, but a little bit of data science. It's mostly data science, but it's a little bit of software engineering. It's all three, and here's why it's all three. You can tell me descriptions for what these things are that are completely different than mine. There's only one wrong answer, and that is it's all software engineering, or it's all data science, or it's all product engineering. I think if you are convinced that it's just one of the three, go do it for 6 months and come back.
Well, this interview has now become a must watch for anyone interviewing for Bryan's team. So we'll make sure to include that in the show notes. All right, Bryan. So just to close up here, I'm curious to learn more about what's up on Hex Magic's roadmap. What are some of the features you're excited to share, if you're able to share?
We got a release coming soon. We're rolling out magic analysis more broadly. We will have more details on that shortly. I can't say too much right now, but it's a big, exciting improvement. And yeah, I'm really, really stoked about where we've gotten to on that product. We've also got some open headcount. So, looking to expand the team, both on the software engineering side and on the AI engineering side. And yeah, I would say sort of like you should be looking out for more of the power of Hex, only a prompt away.
Awesome. And where can folks learn more about your book on modern recommendation systems and try Hex Magic for themselves?
Yeah, you can go to buildingrexsys.com, or you can go to the O'Reilly site and type in my name, or building production recommendation systems, or you can type in Hector Yee's name, my co-author. You can also go on Amazon. It's on there. Yeah, all in all, it's an O'Reilly book, and it's written in Python and JAX. For those of you that are thinking like, oh no, it's in JAX, I challenge you. JAX is a great language, and you should learn it, and here's your chance.
Perfect. And where can folks find you?
I'm on Twitter. I'm also on LinkedIn under my normal name. And then I'm on Twitter, B.E. Bischof, or Dr. Donut is my display name. So yeah, feel free to follow me there. I mostly shitpost, so have fun.
That's the best type of follow. Well, that was a lot of fun, Bryan. Really appreciate it. And thanks again for joining the show.
Yeah, thanks a ton. It was super fun to chat about these things and get into it.
Awesome.